Hi, I'm Eric Reinheimer, professional pilot on the PC-12 and POPA board member. We're here in Dallas at FlightSafety this week. I'm here with Rod Kellogg, CFI and professional pilot.
Yep, thanks, Eric. Here in Dallas at FlightSafety, we're going to be looking at the loss of control accidents in the Pilatus fleet. Over the years, we've seen the loss of controls being the leading cause of fatalities in the Pilatus fleet. We're going to discuss all of the factors that might lead up to a loss of control event. Autopilot disconnect seems to be one of the initiating points for a lot of these upsets. We're going to look at ways to mitigate the upset. We're going to look for the distractions that lead up to these type of upsets, and we're going to talk about what results in an autopilot disconnect, whether it be an accidental pilot disconnect, bump in the control, meteorological issues such as icing or turbulence that lead to the upset. We want to also stress the importance of maintaining a level of proficiency in hand flying the aircraft so that we're always in a position to overcome an upset if it were to develop from losing automation. Having these robust avionics systems puts us in a position where we rely on the avionics all the time. And we want to make sure that we'll be able to handle the aircraft appropriately if an upset does occur. So let's review some of these loss of control accidents. In 2023 in Nevada, climbing near cruise altitude at night during a winter storm warning with reported moderate icing, the plane came off autopilot and veered to the right. The pilot turned back on course to the left briefly, then lost control. Portions of the right wing and horizontal stabilizer came apart from the aircraft in flight. In 2024, we had a crash in Wyoming where the PC-12 was in level flight level 260, when it entered an area of reported turbulence. The pilot reported loss of the autopilot and declared an emergency. During a 270-degree turn to the right, the plane climbed 1,500 feet, then descended 2,000 feet, then climbed to 1,500 feet before stalling. Two sections of the left wing and various other fragments came apart from the aircraft in flight and were located about a mile from the main wreckage. In 2023 in Texas, while on an RNAV GPS approach in IMC in an overcast layer, the pilot was vectored through the final approach course. The controller gave him a heading to turn back and rejoin the final approach course, and the plane rolled into a steep right bank, descended at a rate of 15,000 feet per minute, and impacted the ground.
Rod, we're about to go into the simulator here at DFW. We're going to talk about lessons that we can learn from some of these tragic accidents and how we can prevent these from happening.
Yeah, absolutely. We want to take advantage of these terrible situations so that we learn as a community how to prevent them. You know, as we go into the simulator, we're always in a position where we've briefed the scenario. We're always one step ahead of these crews that were flying these aircraft where everything unfolded rapidly and unexpectedly. So we want to explore the scenarios that lead to the upsets, autopilot disconnects, whether accidental or induced by weather conditions we talked about before. We want to sort of explore what happens when everything's running smooth as far as we know, and then at an instant everything changes and our world turns upside down. We've got to prioritize our actions. We've got to seek out the help of all of the assets that we've got out there, the resources of ATC. Let them know that, hey, we've got a problem. We're going to deal with our priorities right now, sort of put that responsibility on them for taking care of all the other distractions that might be coming up. We need to make sure we keep the plane flying, level the wings, make sure our energy state is appropriate. Our number one job is survivability. We want to take everything we can from these scenarios and the data that we have and employ them in a manner that helps us all survive and makes us a stronger community. In November 124 Papa Charlie, as you're climbing, we've had icing reported between 17,000 and flight level 200.
One Papa Charlie, thank you for the report. Better turn my wing icing light on. Oh yeah, definitely some ice out there. I don't really like that. Better. Separators open, prop on, boots on, ice protections there.
November 124 Papa Charlie, for traffic, make a right turn 200. We have some new routing for you. Advise ready to copy.
And 200 for traffic. One Papa Charlie.
Bank angle. Bank angle.
November 124 Papa Charlie. It looks like those winds are a little stronger. Continue that turn to 240.
240, 1 Papa Charlie.
Bank angle. Bank angle.
All right, Eric. Why don't you walk us through some of the feelings you experienced during the icing demonstration? We had an upset situation occur because of sort of a mismanaged icing encounter.
Sure. Yeah, we started, ATC notified us that we were experiencing some icing conditions, and so when we looked outside, we were indeed experiencing that. We turned on our ice protection, and in doing that, kind of got distracted. We lost autopilot, and then things just kind of escalated from there.
Sure.
As we went through the process.
What are some items you think you could have managed better, or some different approaches you could have taken to sort of mitigate some of the calamity that resulted?
Sure. It would very easy to get distracted when you're looking at all the things compounding on top of themselves. Just flying the airplane would be step one.
Right.
And making sure that we're not getting behind the airplane at all, not getting distracted by a radio call from ATC or whatever else it might be. Making sure we're managing the aircraft is first and foremost.
Yeah, absolutely. Did you find that you were having issues when you went into pusher ice mode as far as energy management, or do you feel like that special consideration is required for that?
I think you want to make sure you're still keeping your airspeed up there, because once you do engage your pusher ice mode, you're going to be experiencing a higher stall speed, or a higher angle of attack where you're going to get that pusher.
Right, absolutely. So, and one of the things is you're a Minnesota-based pilot. Operationally, you've flown this aircraft in icing conditions a lot, correct?
Yeah.
Really, operationally, is there much concern when you enter icing conditions as far as trying to figure out ways to strategically get out of icing, or can you just operate in the normal envelope without much concern?
You can operate in the normal envelope. I mean, you don't want to stay in severe icing or
Sure.
moderate icing. You always want to have a way to get out of that. But the airplane will handle ice, and the ice protection systems are there to keep you out of trouble.
Right, and so I think part of the demonstration that we put on here, we do hear from the field that occasionally folks try to modify what would be a normal procedure operating in the icing pusher ice mode, thinking they can outclimb the ice quicker by having a higher angle of attack and possibly even a slower airspeed to achieve a higher climb rate. And that's really probably not the best approach. It's not that it's probably not the best approach. It's not the best approach. The plane handles ice well. I know from my operational experience, and I'm Alabama based, I don't see near the ice that you see. But again, you say operationally, the plane never presents much of a challenge in icing. So it's important to maintain the normal profiles the manufacturer recommends. Don't worry about getting off speed and having to climb out of the ice. You've got enough horsepower to carry you through, and the systems are effective enough to shed the ice if need be, right?
Correct.
So again, let's talk about operationally when we are in pusher ice mode, some of the factors that are coming into play. You had talked about the envelope change there for you, and then also the stall shaker speed being increased. So we have a tighter margin of operations. Any other items that come to mind for you?
I think, especially night IMC, you're maybe a little bit more focused in the cockpit than outside. If ATC doesn't give us a warning, do we even have our ice light on? Are we even monitoring for any of that stuff? So also other indications inside the cabin, I think, are other good ways to...
Yeah, absolutely. I mean, we need to monitor our trim if we suspect we're in icing conditions, see if there's any kind of abnormal trim operations going on with the autopilot on. I think a point that we had discussed earlier too is you brought up, hey, if you're flying in icing conditions for a sustained amount of time, take it off autopilot occasionally, feel it, make sure the plane is staying stable and set, so that if you had an inadvertent autopilot disconnect, that you're not all of a sudden holding on to an airplane that's bucking and going away.
Right, and I think in our scenario here, we were very surprised by the autopilot kicking off and the effects that ice buildup already had on the airplane,
Right.
and that resulted in the upset.
Right. And I think another thing too is speed management. Again, we talked about keeping that higher energy with our airspeed, because as we slow down, we get a higher angle of attack. It actually changes the way the ice can form on the wing, and there's been some notable accidents where sustained flight at high angle of attacks, when the autopilot does kick, all of a sudden you have a wildly different airframe,
Correct.
Airfoil that you're working with.
Nice day. Pretty smooth out. Can really see all the terrain features and elk and whatnot. Oh, well, I guess I spoke too soon. Now it's getting really bumpy. Oh, that's fun. 260. Oh, there it goes. Kicked my autopilot off right away. Re-engage that. Re-engage. All right. Oh man.
And November 124, Papa Charlie. Next sector's request, come left to a heading of 220.
Re-engage that autopilot. 220.
Bank angle. Bank angle. Bank angle.
Oh,
Bank angle.
really fast. I gotta get back. I gotta get back up to my altitude.
Speed.
Bank angle. Bank angle. Bank angle. Bank angle. Bank angle. Bank angle.
Clear.
All right, Eric, so this is our redemption flight, right? We're going to reset that same scenario that we had prior, where we're flying around, cruising at altitude. We had smooth air, we start running into some turbulence. And we're out west, we're probably running into some geographical turbulence. Here's the turbulence coming on. And we're
feel it.
We're going to end up losing the autopilot through some turbulence upset. So if you want to go ahead and jump on the controls there, there's the autopilot fail. Now, let's just go ahead and set up an upset here, and I'll just kind of make it bad for us here initially. All right, you've got the airplane
Bank
now.
angle.
My airplane.
All right,
Bank
before
angle.
you were really obsessed with
Bank
trying to
angle.
keep the altitude.
Bank angle.
So let's, first of all, let's just get our power set kind of in the middle here. And let's really focus with two hands, just fly in the picture, right? Get that PFD where we're level in flight. ATC, we're not worried about altitude anymore. So we're gonna say ATC, unable to maintain altitude. We'll advise when we're ready to accept altitudes again. All right, that's immediately gonna let him know that we've got something going on. All right, anything that's gonna help us here, we can center up. We're just gonna two-hand fly this thing, get it stabilized, get control of the aircraft. Now, we actually haven't come off our altitude real bad here, but if we were in some severe downdrafts, we're not gonna worry about it. We're 10,000 feet from the nearest structures, right? No terrain to worry about in the high 20s in the United States. Make the primary focus of your flight at this time just maintaining stabilized control.
Okay.
All right, if we've got severe turbulence, we're just gonna fly the airplane, keep ourselves safe and alive. So Eric, tell us a little bit about what you experienced on the turbulence upset and the recovery techniques, some of the things that you prioritize that maybe you wouldn't prioritize or make some adjustments.
Yeah, we started experiencing that severe turbulence, and I think there was some overreactions there. We probably should be more focused on keeping the wings level and bringing our power out to get some of those stresses off of the aircraft than trying to worry about altitude and just flying the aircraft first.
Yeah, so I think the moment you find yourself making choices between maintaining assigned altitudes and maintaining controllability needs to take the cake there. Engage ATC at that point. Let them know that, hey, we're unable to maintain altitude. Declare an emergency. There's no harm in that. No paperwork, no hassle. You're just alerting ATC that, hey, things aren't going good for me right now. Let's use the whole system to assist.
Yep.
Yeah. And November 124, Papa Charlie, right turn to 290.
1 Papa Charlie, 290.
1 Papa Charlie, you can descend to 4,000 feet.
Down to 4,000, 1 Papa Charlie. take me through here. I gotta get down here. It took me through. Oh, my approach didn't even arm.
November 124 Papa Charlie. I show you 5 miles from temp. Right turn to 030. Report established inbound on the RNAV 36.
Right turn to 030. Man, you took me all the way through the course here. Now I got to get all the way back there.
That's why I gave you 030, sir. We had some traffic on the right side.
030. One Papa Charlie.
Papa Charlie, just report established for
Bank
the
anchor.
RNAV 36.
Bank angle. Terrain. Pull up.
All right, Eric. Let's talk about the vectors into the approach where you went through the final approach course. ATC brought that on you, but it wasn't something you anticipated. What were some of your takeaways? How did you sort of manage the unexpected?
Yeah, I think initially we were coming in with a lot of speed, kind of in a hurry, wanted to intercept that final approach course, and not having that planning there to realize that we were going to maybe overshoot that course until it was too late. So we flew through the course. The controller didn't give us a vector in time, so I'm mad about that, and that all compounds to the point now where when he does give me that, I'm upset. I'm trying to hurry up and get back onto that final approach course, and the autopilot's not turning quick enough for me, so I'm trying to put some extra input in there. That kicks off the autopilot, and all of a sudden now I'm in a situation where I'm fast still. I try to pull power out, and we get into a little bit of an upset situation in IMC.
Right. Very much the definition of an unstabilized approach, and you're in actual IMC conditions. Sometimes we're in a position where ATC is making decisions for us that A, we're not prepared for, and B, when we had more time to think about, would probably say they're not the best position for us to go into an approach scenario. In this one, ATC, for whatever reason, took us through the approach course, didn't alert us ahead of time. So we have a big turn coming back for the re-intercept. That's the moment where you might need to step back as a pilot. Don't let the frustration get to you. Maybe just ask for another vector back around for a more stabilized approach.
Right.
Again, don't allow yourself to be pulled into that scenario where you're putting in high bank, overriding the autopilot system, or even disconnecting the autopilot system, trying to comply with this directive from ATC. The picture for them is different from the picture for us.
Mm-hmm.
So Eric, after looking at these scenarios today, I think we can understand the importance of improving our abilities to recover from these upset scenarios. We talked about maintaining proficiency in the hand flying, just in normal operations, but we also need to put special attention in recovery and upset recovery training as well. NASA's had studies that show that we have about a 10-second window to resolve these upsets. That's a pretty small time frame. Unfortunately, not many of us in the fleet are training more than 60 seconds a year in upset recovery. We typically are just doing a couple of upset recoveries a year. We do have vendors that provide training for upset recovery, including FlightSafety. We have some in-aircraft options as well. So I think it's vitally important that we add that to our training syllabus annually, and we seek out those resources so that we become a stronger, safer pilot community.
I agree. POPA's got some great partners out there, including FlightSafety, and we encourage everybody to go out, use those, become more proficient, and let's help our community be better together.
Absolutely.